All right, so today we're diving into something pretty deep, space-time algebra, or STA.
Right.
And we're looking at excerpts from David Hestenes' book, Space-Time Algebra. Now, this isn't just some, another mathematical theory. This is Hestenes' claim that STA is really a new framework for understanding the universe at its most fundamental level.
Yeah, that's right. Hestenes argues that STA can unify our understanding of physics from, like, special relativity to quantum mechanics.
Wow.
And even offers a new perspective on electromagnetism and gravity.
So he's basically saying STA could rewrite the physics textbooks as we know them. What makes him so sure about this?
Well, I mean, it's a bold claim.
Yeah.
And it all hinges on the way that STA blends algebra and geometry in a really intuitive way. For example, instead of thinking about space and time as separate entities, STA treats space-time as a unified four-dimensional structure.
Okay, so instead of our usual 3D space plus time,
Yeah.
it's all one interconnected entity. How does that change things?
Well, think about it this way. At any given moment, you have a whole range of potential actions you could take.
Right.
That's kind of like what mathematicians call a tangent space.
Okay.
At a specific point in space-time.
So my personal space-time has all these possible paths branching out from each moment.
Yeah.
That makes sense, but how do we actually represent those paths mathematically?
That's where the algebra in space-time algebra comes in.
Oh, okay.
It gives us a way to describe and manipulate these geometric objects, points, lines, planes, even volumes, directly as elements in an algebraic system.
Right.
So instead of just having a vague notion of a tangent space, we can use vectors to represent specific directions and magnitudes within that space.
So it's like having a detailed map.
Yeah.
Instead of just the set of coordinates.
Exactly.
That's starting to sound a bit more manageable than I expected.
Yeah.
But what about those notoriously complex equations we always see in physics? Does STA somehow simplify those too?
It does.
Okay.
One of STA's strengths is that it can make those equations more elegant, more insightful, and more connected to the underlying geometry.
Okay.
A prime example is its approach to those infamous Pauli and Dirac matrices used in quantum mechanics.
Those always seem so abstract and confusing. What does STA do with them?
So Hestenes claims that these matrices, which are often shrouded in complexity, are actually representations of space-time vectors within STA. They're not just convenient tools. They're fundamental geometric objects.
So those matrices, which always felt like mathematical sorcery to me, are really just vectors pointing around in space-time.
That's the idea.
It's amazing how STA seems to strip away the mystery and connect these concepts to something more visual and intuitive.
Exactly. And that's what Hestenes is getting at. He's suggesting we might understand these concepts better if we stop thinking of them as just abstract symbols and start seeing them as geometric objects in space-time. In fact, he makes an even bolder claim about one of the most fundamental and perplexing elements of quantum mechanics, the imaginary unit, I.
Yeah, the square root of -1.
There it is.
Always a recipe for a headache, even for someone who enjoys math.
Most physicists just accept imari as this necessary but mysterious mathematical tool. But Hestenes argues that an STA emerges naturally from the structure of space-time itself.
Wait, so that imaginary number that's haunted math students for centuries actually reflects something real and fundamental about the universe.
That's what he said.
That's wild. How does that even work?
It's related to something Hestenes calls the space-time split. But to really grasp it, we need to understand how STA handles another fundamental force, electromagnetism. You're familiar with Maxwell's equations, right?
Yeah.
They describe how electricity and magnetism work. But they can be incredibly dense and difficult to really grasp.
I vaguely remember them from physics class. Lots of Greek letters and complex relationships.
Exactly.
Are you saying STA can make even Maxwell's equations easier to understand?
That's exactly what Hestenes proposes in STA.
Yeah.
Instead of dealing with electric and magnetic fields as separate entities, we combine them into a single entity called a bivector. This simplifies Maxwell's equations significantly and offers a more unified perspective on electromagnetism.
So like with space and time, becoming space-time.
Right.
Or those complex matrices becoming vectors. STA finds a way to unify electricity and magnetism.
Yeah.
That's pretty elegant.
Yeah, this unification isn't just about mathematical neatness, though.
Right.
It suggests a deeper connection between these forces than we previously understood.
Okay.
The way STA represents this combined electromagnetic field as a single geometric object, a bivector, could lead to new insights and discoveries about how electromagnetism works at a fundamental level.
It's starting to feel like STA has this knack for revealing hidden connections between things we thought were separate.
Yeah.
Like it's weaving together a more elegant and unified tapestry of the universe.
Yeah.
It makes you wonder what other secrets might be out there, waiting to be unlocked with the right mathematical language.
Yeah.
So what else does Hestenes tackle with STA? So what about gravity?
That's where it gets really interesting.
Okay.
Einstein's theory of general relativity tells us that gravity is a curvature in space-time.
Right.
Well, STA gives us the tools to describe this curvature in a very natural way.
So instead of thinking of gravity as a force pulling things together, we can visualize it as the actual bending of the space-time fabric.
Yeah, that's the idea.
I'm starting to see why you were so excited about this.
It's a powerful way to visualize a complex concept.
Yeah.
But Hestenes doesn't stop there.
Okay.
He also introduces us to the concept of spinors within STA.
I'll be honest, I've heard of spinors.
Okay.
And they always seemed incredibly abstract.
Right.
Like something only theoretical physicists could grasp.
And you're not wrong. They can be quite abstract.
Okay.
But in STA, they take on a more intuitive meaning.
Okay.
Instead of being purely mathematical objects,
right,
spinors in STA describe how particles, like electrons, orient themselves within this curved space-time.
So spinors are like little compasses inside particles, helping them navigate the twists and turns of space-time created by gravity.
That's a great way to think about it.
Okay.
It highlights how Hestenes continually brings these abstract mathematical concepts back to the physical reality of space-time.
Right. This is a lot to process.
Sure.
But I have to say it's incredibly fascinating. We've gone from unifying space and time to reimagining matrices as vectors, and even simplifying Maxwell's equations.
Exactly.
It feels like we're only scratching the surface of what STA can do.
We are. But what's crucial here is the potential of STA. It might not just be a more elegant way to express existing physics.
Right.
It could be the key to entirely new discoveries.
So what does that mean in practical terms? Where could STA lead us? So we've seen how STA can kind of reshape our understanding of electromagnetism and even gravity. But where could it lead us in the future? What are the big unanswered questions that STA might help us tackle?
One of the most exciting prospects is its potential to help us finally unify quantum mechanics and general relativity.
Right.
The two pillars of modern physics that have kind of stubbornly resisted unification for decades.
You mean finding a theory of quantum gravity?
Yeah, exactly.
That's like the holy grail of physics.
It is.
What makes STA a good candidate for cracking that nut?
Well, remember how we were talking about how STA handles both the discrete nature of quantum objects, like spin, and the continuous curvature of space-time and gravity.
Right.
That's a pretty unique advantage, right?
Yeah.
Hestenes believed that STA could provide the right language for describing the universe at the Planck scale.
Okay.
Where those quantum effects and gravity become equally important.
So instead of having two separate rule books, one for the quantum world and one for the cosmos, STA could provide a single unified framework for both.
That's the hope.
That's a pretty mind-blowing concept.
It is. And if it pans out, it could revolutionize our understanding of everything from black holes to the Big Bang.
Wow.
But even beyond quantum gravity. STA has the potential to impact other areas of physics as well.
Okay.
For example, some physicists are exploring its use in simplifying complex calculations in areas like fluid dynamics and even computer graphics.
So even if someone isn't particularly interested in the deepest secrets of the universe, STA could still have practical applications in their field.
Absolutely, and that speaks to the power of theoretical physics in general, right?
Yeah.
Sometimes the pursuit of abstract mathematical elegance can lead to tangible, real-world benefits that we never anticipated.
I have to admit, I started this deep dive feeling a bit intimidated
Sure.
by the math involved.
Yeah.
But you've made it so much more approachable.
Well,
It's not just about equations.
Right.
It's about finding a new language to describe the universe and uncover its hidden patterns.
I think that's what's so captivating about Hestenes' work.
Yeah.
He wasn't just playing a mathematical game.
Right.
He was searching for a deeper truth about reality.
Right.
And even if FTA doesn't end up being the final answer,
Right.
it challenges us to rethink our assumptions
Mm-hmm.
and explore new ways of seeing the world.
This has been an incredible journey.
It's been fun.
It really has. And it's definitely sparked a curiosity in me to learn more for our listeners who feel the same way.
Yeah.
Where's a good place to start?
Well, Hestenes' book, Space-Time Algebra, is a great starting point.
Okay.
Though it's definitely a challenging read.
Okay.
There are also online resources and courses available
Right.
for those who are interested in a more structured approach. A quick search for Space-Time Algebra will lead you to a wealth of information.
And for anyone who's ever looked up at the night sky and felt a sense of awe and wonder, or pondered the fundamental nature of reality, exploring the world of space-time algebra might just deepen that sense of awe.
Yeah, I think so.
It's a reminder that the universe is full of surprises.
It is.
And that our quest to understand it is far from over.
Well said.
Thanks for joining us for this deep dive
Of course, yeah.
into space-time algebra. Until next time, keep exploring.